As far as extragalactic astronomy is concerned, 2022 has been a great year so far. First, astronomers discovered the most distant galaxy ever known in the universe. This galaxy has been named HD1 and has a light travel distance of 13.5 billion light-years. It's about 100 million light-years more distant than the previously known farthest galaxy. And now, a team of astronomers has discovered the most distant single star ever known in the universe. This star has been named Earendel, and it might belong to a rare population of stars astronomers have been searching for decades. But how did they discover a lone star so far away in the universe? How big is this star as compared to the Sun? And most importantly, what do we expect to find by focusing the James Webb Space Telescope on Earendel? Before Earendel, the record of the farthest known star was held by a blue supergiant named Icarus. The light travel distance to this star is 9.34 billion light-years, and the proper distance, which considers the universe's expansion, is 14.4 billion light-years. But Earendel lies much farther away than Icarus, with a light travel distance of 12.9 billion light-years, and a proper distance of a staggering 28 billion light-years. That's a huge leap back in time, because Icarus existed when the universe was about 4 billion years old, but Earendel was there in the first 900 million years of the Big Bang. This means that this star is about 8.2 billion years older than the Sun and the Earth. So far, the smallest objects observed at these distances were star clusters embedded in distant galaxies. But Earendel is the first isolated star found at such a large distance. This star was discovered by chance using the Hubble Space Telescope. Hubble first observed the star's parent galaxy that was gravitationally lensed by a galaxy cluster in the foreground. Massive astronomical objects such as galaxy clusters distort the space-time fabric around them. As a result of this distortion, the light from the foreground celestial bodies bends when it passes close to these massive objects. Because of this gravitational lensing, the background galaxy containing Earendel appeared like an arc that the astronomers named the Sunrise Arc. But the team saw a bright object sitting on the edge of the distorted galaxy. Luminous sources in distant galaxies tend to be highly energetic events, such as novas, supernovas, or tidal disruptions caused by black holes. These are transients that happen to change their brightness with time. However, Hubble's observations showed that the brightness of this object remained constant for over 3.5 years. Hence, astronomers concluded that it's a gravitationally lensed bright star in Sunrise Arc. The research team estimates that Earendel is at least 50 times the mass of our Sun and millions of times as bright, rivaling the most massive stars known. But even such a brilliant, very high-mass star would be impossible to see at such a great distance without the aid of natural magnification by a colossal galaxy cluster sitting between Earendel and us. The mass of the galaxy cluster warps the fabric of space, creating a powerful natural magnifying glass that distorts and dramatically amplifies the light from distant objects behind it. Hence, the discovery of Earendel was only possible because the star was at the right place at the right time. Given the star's age and the estimates of its mass, it probably no longer exists. Massive stars such as Earendel use their nuclear fuel much more quickly than small and mid-sized stars. As a result, they have an average lifespan of a few million years. compared to about 10 billion years for sun-like mid-sized stars and up to 1 trillion years for red dwarfs. Hence, Earendel might have died in a fiery explosion billions of years ago. Earendel's discovery is important because it might be the first observation of a population 3 star that astronomers had been hunting for decades. Primordial nucleosynthesis produced 2 major chemical elements, hydrogen and helium. The first generation of stars, known as population 3 stars, had trace amounts of metals and hence a low metallicity. In astronomy, any element other than hydrogen and helium is referred to as a metal. Astronomers believe that most of the population 3 stars have died by now, and the remaining ones are pretty dim and difficult to observe. They're almost impossible to be seen naturally, and most of the candidates have been found in gravitationally lensed galaxies. Unlike Icarus, a blue supergiant star, we don't really know about the spectral classification of Earendel. It could even be a binary star system. However, astronomers expect that Earendel will remain highly magnified for years to come, and powerful telescopes, such as the James Webb Space Telescope, will determine its properties. Webb's high sensitivity to infrared light is needed to learn more about this far-flung star because its light is stretched or redshifted to longer infrared wavelengths due to the universe's expansion. Accurate measurement of Earendel's brightness and surface temperature would narrow down its type and stage in the stellar life cycle. Astronomers also expect to find that the Sunrise Arc galaxy lacks heavy metals that form in subsequent generations of stars. It would strongly suggest Earendel is a rare, massive metal-poor star. Also, it's important to note that this discovery was made using the Hubble Space Telescope, which primarily operates in the optical and ultraviolet regions of the electromagnetic spectrum. Its mid-infrared capabilities can look back up to 500 million years after the Big Bang, but Webb can peer further back in time, up to just 200 million years after the universe was born. For reference, the first stars formed at the beginning of the Stelliferous era, roughly after the first 150 million years, when the universe's temperature was 60 Kelvin. Astronomers believe that Webb can surely break the distance record of the Hubble Space Telescope, and that would be thrilling to watch. Looking for the first stars and galaxies has been a holy grail in astronomy. The discovery of the first generation of stars would help us understand star formation and verify the predictions made by the Big Bang model. Also, searching for them is like searching for our own origins. As Richard Feynman once said, the most remarkable discovery in all of astronomy is that the stars are made of atoms of the same kind as those on Earth. If you enjoyed this video, make sure to like it and subscribe to our channel for more episodes of the Sunday Discovery series.